to estimate the number of unknown cases, first I collect data from the website held by the California Health and Human Service Agency, and I selected a certain period from the data from the March 20 and to March 29th for use for the Poisson description because during that period the number of known cases per day increased all the time. Then, since I was not so familiar with the Poisson regression model, so I used the methods based on the job used to determine the number of unknown cases in Wuhan, China from January 1st to 15th. First, I assumed that there were many underreported cases and I used the dn to represent the number of new cases on the nth day. The first day in here is in the March 20th. And then I use the di to represent the number of known cases and the ni for the number of unknown cases. Hence, they can get an equation. After that, I model the Poisson regression model of the dn series as an exponential growing Poisson process. After that, I estimated the in-streak growth rate of the exponential growth denoted by R based on the log likelihood denoted by L. After that, I used the profile likelihood estimation framework with cutoff threshold determined by a chi-square criteria, PR equal to 0.95, df equal to 1 to estimate the 95% of confidence interval for the unknown cases, the number of unknown cases. As R estimated, we also can obtain the basic reproduction number by the function shown in the paragraph. Show that in the equation of 5. Since it was hard to find the correct information about the transmission chain of COVID-19 because it was a new virus, so I adopted SI information from severe acute respiratory syndrome and Middle East respiratory syndrome, which shared similar pathogens as the COVID-19. Then, to infer the patterns of daily number of cases, I represent the number of cases on the ith day from March 20 to March 29th by pi, and there exists another equation. And then I developed a simulation framework for the iterative Poisson process, which this equation also showed on the PPT. As a result, I made these tables and figures on the PPT to present the number of reported, underreported cases and some of them per day and the interval of them. From this table and figure, we can find that there were very many known cases, which the number of unknown cases was even larger than that of known cases, which means that the actual total number of cases was even larger than 2 times of the known cases. And so it moves. So it leads me to a discussion. First, why there exists so much underreported cases. First is because of that some people maybe have worked at infected COVID-19, but but they do not come to a hospital for treatment, since there are no related symptoms showed on their bodies. Because of their cells may be restricted, maybe because their cells in their bodies may be possess a lot of barriers to prevent the infection. Besides, so in fact there are, although now many California governments have emphasized the importance of the COVID-19 rules, there are still some teenagers who ignore these important rules and play together in the beach. Of course, as you can see in the figure of the results, the red line and the blue lines seem to agree until around April 5, but then started to diverge. The red line also sometimes decreases and sometimes increases, but the blue line increases almost continuously. The reason why the red line fluctuated was results in erratic new cases per day count. The blue was made based on the erratic data and the assumption that the situation of COVID-19 continues become more serious over time. Hence, the number of cases per day also increases. Besides, because my method is based on the one that Zhao used, but the environmental condition is different. In Wuhan, China, from January 1st to 15th, the cumulative number of total cases remained constant. But in California, although in different rates, the number of total cases is increased all the time. Hence, the areas existing in my data will be larger, and the range of error also becomes larger. As a result, as we can see as we all know that, as we can see also in the figure, that there may exist, because due to the fluctuation, it leads me to think about whether there may exist underreported cases because they may not reported in hospitals. So to estimate this number, the specific number of unknown cases, I use the general Poisson regression model, which is a general model for the data counts that we can use to determine the relationship between the responsive variable and the predictor's variable. After that, I search for data from the website and use the equation for the calculation. Finally, I find that unreported cases of number of unreported cases was even larger than that of known cases. For the future research, I will change the direction to estimate the actual number of cases by analyzing the death rate of the COVID-19. Since determine the moral rate, determine the oral rate we will easier than to estimate unknown cases directly. I will also still use the general Poisson regression model to estimate, and then after that, I could use this mortality rate and the known death cases of COVID-19 to determine the total number of cases. Hence, I can find the number of unknown cases. That's all. Thanks for watching.